major scale construct. So, if you imagine that in the beginning of time there was one scale only, and this scale just had all the notes that were available to it, and we call it the chromatic scale. So the chromatic scale is everything from whatever you choose a note to be, through every step in semitones to the end of the universe. That's the first scale in the world, and we call it the chromatic scale. Chroma means colour, chromatic, all the colours of the rainbow flooding into one scale. So here's a chromatic scale. If I start on E, and go... That was a chromatic scale. Sounds dull as ditch water, doesn't it? Now, at some point, some very clever dude decided that if I step through this chromatic scale in a certain way, kind of like hopscotch, jumping over some of the notes, landing on some of them, and pick the ones I land on out, I choose a scale. Almost like sort of picking fat kids to make a basketball team. You know, you weed out the ones you don't want and keep the ones you do. It's the same method. You've got a line of notes, you jump from one to the other in a certain pattern, and the ones you've landed on, pick out and play those. That's a scale. Now, the major scale follows a pattern. It follows the pattern of 2, 2, 1, 2, 2, 2, 1, which is another boring fact you're going to have to memorise. So if you imagine starting on a beginning point, like, here's a beginning point, that's an E. Well, I hope it's an E. I haven't particularly tuned this morning. Yeah, that's an E. If I jump 2 frets, 1, 2, and then jump 2 frets, 1, 2, and then jump 1 fret, 2, 2, 1, I get the sound of a major scale. So, applying a pattern to pick notes out from a chromatic scale is how the major scale was born. So, for ease of reference, what we did, we, the school of cunning guitar teachers, is we number each of the notes in the scale we've chosen, the major scale. So we just call them 1, 2, 3, 4, 5, 6, 7, and everyone knows what you're talking about. And the second thing we do is, rather than play them in a straight line, play them in a scale going down the neck, sometimes, and it makes them easy to fit in your fingers, and you have a major scale shape. So let me teach you a simple and very useful major scale shape. And I'm going to start this scale on the A string, because at some point we're going to need to use this big fat E string here to drone when we start doing some modal theory. So here is a major scale shape, and this one is going to be in the key of E for you. Here's a close-up. So as you can see, I've started with my second swearing finger here on the 7th fret. Now I have a reason for this, bear with me. Once I've picked this note, that's my E, I'm going to put my little finger down, up a tone, 2 frets, and then change string to the first finger at the 6th fret. And that's why I started with my second finger, so my first finger lies directly on top of that third note. So far we've got this. Keeping my wrist nice and classical shaped. So note number 4 is right next to it with the second finger. Note number 5, little finger. Down a string again to the G string with the first finger, 6th fret. That's the 6th note. 7th note with the 3rd finger. Little finger to the last note. Now that last note is commonly referred to as an octave. I'm going to briefly explain what octave means, just in case you don't know. So if you imagine that a note is a vibration, here's my arm being a vibration, and as I shorten the string by putting my finger on it, you hear a higher pitch. What actually happens is the string gets shorter and shorter and vibrates faster and faster. So the faster the vibration, the higher the pitch that you hear. Now, if I start with a note like E, that's for example 430 vibrations a second. I don't know, it might be. It'd be great if it was. If I speed it up, speed it up, speed it up, and it gets higher and higher and higher, at some point you're going to get to a note which is exactly twice as fast as the original vibration. Sounds like a reggae band, doesn't it? And that's the octave point. So here's a vibration. Here's a point that's exactly twice as high in pitch and twice as fast a speed of vibration. So that's what an octave is. It's just a mathematical point where you've started somewhere, got to somewhere else, and the place you've landed on is exactly twice the speed of vibration as your original starting point. So there are many areas like that within a scale that we call fifth and seventh and third and all this kind of stuff. And I'm going to explain now why we name things like that within a scale. It's very simple. Basically, like I said previously, everything's numbered for ease of reference. So on your scale, the first note is called number 1. You might also hear that being called a root by classical dudes. Second note is called 2. Third note is called a 3. 4, 5, 6, 7, 8. 8 being the octave. Ah, I've got an email. So we number all these notes in the scale. Now, why do you need to know that? Here's the reason why. When we make chords, we name the chords from the notes used in the scale to make them. So, for example, if I took my scale and I chose the first note, the third note, fifth note, and the seventh note, and put those all together, you get a chord with a 1, a 3, a 5, and a 7. Now, a 1, a 3, and a 5, if you marry those together, we just call that a major chord. A major chord is a 1, a 3, and a 5 from a major scale. And when you put a 7 into it, we call it a major 7. So you name chords from the origins of the notes taken from a scale. That's why you get these minor 7, flat 5, diminished 8, 11, 10. All these numbers are referring to what they're made from within a scale. So there are a couple of other things to know about this. The first is that the third note of this scale, 1, 2, 3, we call that a major third. The reason for this is that it's born from the major scale, it's inside a major scale, it sounds happy, and if I move it back, it sounds kind of maudlin, really sad. So the fact that you can move this note backward by one step and it sounds sad has power over music. So we refer to the third note as the major note, the major third. And if you bring it back by one step, we call it the minor third. And the same rule applies to the sixth note of the major scale. If I go, that's my sixth note. If I play that with the first note together, I call that sixth. If I take that sixth note back by one step, it sounds sad. It's just a fact. So the third note and the sixth note of a major scale have the power to make you feel sad if you bring them back by one step. Therefore, we refer to them as the major third and the major sixth, and if you bring them back by one step, we call them the minor third and the minor sixth. Now, actually, every note inside the scale has an effect like this if you move them, and that's a whole topic called intervallics on a different type of tip. So, how do you make a scale? You start with all the notes, jump through them in a certain pattern. To make the major scale, you do 2, 2, 1, 2, 2, 1. And you might hear that being called tone, tone, semitone, tone, 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 semitone, which is the classical reference for the distance of 2 frets and 1 fret. 2 frets is a tone, 1 fret is a semitone. That's how you make a major scale. We number each note in the scale 1, 2, 3, 4, 5, 6, 7, and 8. 8 is the octave, which is the speed of frequency twice as fast as the original note. And there you have a major scale.